I don't know, I'm not very good at April Fools. So April Fools, here we go. There was no fool. Welcome. Let's see here. I had a bit of a startle when I flipped to April on my calendar, and our test 3 is next week. Scary. On the plus side, it'll only cover, right, chapter 6 and as far as we get in chapter 7. I suspect we'll kind of get through quite a bit of chapter 7 because nothing really changes. But just as a heads up, or kind of warning, I guess, warning, test number 3 is on next, I know, I wish it was an April Fool's. I wish I could do that for you guys. I so wish. Test number 3 is on Thursday, April 8th. So I guess I gotta make a practice test. Huh. So stay tuned for that. I'll be working on that. But like I said, it definitely kind of took me by surprise. That was an April Fool's on myself, I guess, not on you guys. You guys have a pretty good handle on things. So that's my warning. You've also got 1 or 2 assignments due tonight. So make sure you do assignment 7 and assignment 8, which is assignment 8 should be pretty quick, right? It's just getting used to working with those different rate manipulations. So, all right. Last day we talked a lot about annuities, and we talked about the importance of changing our interest rate to match the compound, or sorry, the payment frequency. Why did I say that? There is my April Fools. No, so we started a question, and I think probably the best way to go about it is to just start it fresh so that we have it all in one go here. Where am I? Or maybe I should grab it from here. What we did was I jumped ahead to 6.4, and then what we're going to do is we're going to go back and go through 6.3 because I was running out of time, but I wanted to introduce a situation where the compounding rate was not the same as the payment frequency, right? And so because that's what we're going to need to be able to solve these problems. So we're kind of going to jump around a little bit today, but we'll get through it all. So I'll just make a note here. We jumped to 6.4, but we'll go back to 6.3 today. When we do 6.3, you'll see why we were able to do that. It's because it's a standalone section. So we started this problem, example 218, and first thing we did, well, of course, first thing you do is read the question carefully. And there's a lot of information, right? It's not a very long question. Whoa, pulling it along here. It's not a very long question, right? But there's a lot of information here. So we're making month-end payments of $300 for 4 years. Okay? So if the rate of interest is 5% per year compounded quarterly, what's the value of the car, right? Meaning how much did you pay today, right? What's that value that you're paying off with these $300 payments? So what I want you to get in the habit of doing is first thing you do is figure out what your compounding frequency is and what your payment frequency is, right? And so first thing, well, sometimes I'll draw the timeline first. Sometimes I do the compounding frequency and the payment frequency first. So, because I want that to be kind of a hurdle that you get over right away, finding I2. Remember, we have to adjust our periodic interest rate to match the payment frequency. So I've got month-end payments, okay, and I'm compounding quarterly. So these are not the same. My compounding is quarterly, so 4. And my payments are monthly, so I'm making 12 payments per month. And just as a note, right, you're currently compounding quarterly, so that's going to be your F1. And you want to be compounding monthly, so that's going to be your F2. Okay, and that's an F. So we also have that I1 is the current periodic interest rate, which is 0.05 over 4. 0.05 over 4, I don't know, is 0.0125. Okay. So now I want to adjust that to be a monthly periodic interest rate. So I2, right, we said these are not the same. These are not the same. So we need to find I2. So I2 is going to be that I that we use in our calculations. Now we have 1 plus I1 to the power of F1 over F2 and then minus 1. Plugging in our values here. And sometimes what I'll do is I'll get lazy and I'll just calculate I1 inside here. That's fine, you can do that. And so I have 1 plus 0.0125 to the power of, and this is where it's really important, you're going from quarterly to monthly. So that's how I read these, right? From quarterly to monthly, and then minus 1. So 4 over 12 and then minus 1. When you do this calculation, right, remember the 4 over 12 all has to be in the power. So now if you go ahead and do this on your calculator, I'm going to go to our free app. Try DocuSign. I have things. Hey, you went away with that. Oh, cool. It's listening. So just for kind of completeness, I'm going to start by calculating I1. So 0.05 divided by 4. And then I can add 1. And then I have to raise it to the power of 4 over 12, making sure 4 over 12 all is in the power. So I have to use brackets because I was playing around with it. And if you don't use brackets, then it doesn't work. So that's to the power of bracket 4, hopefully it changed, divided by 12. The hard part with this calculator is it doesn't show you what you've hit or what it's doing, but that looks reasonable. So then minus 1. But I accidentally did hit the multiplication instead of division. So hopefully you guys get the same thing. I'll do it on here. And see, I do get the same thing. So I'm going to store this in 1. Okay. So I get, this is going to be 0.0041494225, which I'm storing in 1. Right. So, okay, that's going to be the I that I use. We don't actually know what we're doing yet because we haven't made our timeline, and that's okay. But as long as you kind of get that over with finding I, then the rest is easy. Well, not easy, but the rest is easier. Okay, so you're making payments of $300 for 4 years, okay? And the rate of interest is 5%. We already found our I, and we want to find what's the value of the car. The value of the car is the value of the car today, right? So whenever you're paying something off, you're usually calculating the present value, or you know the present value. So if we have our timeline, we're going to start today, and I'm going to write the 4-year mark up a little bit higher because our payments are monthly. So I'm going to convert 4 years to months just so that it looks a little bit nicer. But I'll still have the 4 years here. And let's see here, 4 times 13, that's bad. 4 times 12 is 48 months. That sounds more reasonable. Okay. And then remember how we're going to draw our timelines for an annuity. You're not going to have to do 48 ticks. That's crazy. Don't do that. Even though that's technically what we're doing, but we have formulas to get around that, right? So I want to see the first 3 ticks and the last 2 ticks at least. Okay. And so the first tick is at the 1 month mark, or sorry, the second tick. Today I'm counting as a tick. Today, 1 month, 2 months. And then picking up at 47 months, make sure you use that ... to show that it keeps going like that. You get the idea. Okay. So the payments are being made at the end of each month. So even if you start, so you sign the contract today, you would be making this first payment of $300 just before the 1 month mark, right? Just at the very end of today's month, right? And so what we do is we write this $300 under the 1 month mark. And so we have $300 here, $300 here, $300 here, and $300 here. Right. That's the only thing that's going to change from chapter 6 to chapter 7. Chapter 7, we make payments at the beginning of each month, for example, so then all these get shifted over to the beginning of each month, and then we have to adjust the interest. But that's all that's happening in chapter 7. So that's why we're going to get there pretty quickly. Okay. So how do we solve this? Well, we want to know the value of the car. The value of the car is the value today, right? And so that's generally going to be, if you're paying something off, the value you're interested in is the value today. Because in theory, at the end of 4 years, the loan is paid off. So the future value should be 0, right? So we ignore that. So to show that all of these payments are contributing towards paying off one value, we use a kind of a funnel. I use a curly bracket because I think they're really fun to draw. You can use a square bracket if you want. As long as you kind of funnel them together to make one present value. And that's the value today. That's the value of $300 monthly for 48 months. Okay. Remembering that N is now the number of payments, right? So N used to be the number of compoundings, right? But now it's the number of payments. So N is now going to be, it's still the time times F2, right? The frequency, the payment frequency, which is going to be 4 times 12, which we already found was 48. Right? And we already found the I that we're going to use in our calculations. So I'm just going to keep it there because it's, you know, close enough to the timeline. I'm not going to rewrite this again. So if I want to find the present value here, then I have to use a present value formula. So let's get acquainted with these annuity formulas again. Oops. We have 2 options, but only one of them is going to work, right? Here, this is if we're solving for the future value, and what we established last day is there is no present value in here, right? PMT is the payment amount, I is going to be I2, N is the number of payments. So there's no present value in this formula, right? So you can ignore that one and just focus on the present value formula. So it's important that you know which one you want to solve for, because that's going to determine which formula to use. So now I can use the present value is the payment amount times 1 minus 1 plus I to the negative N over I. Now, we worked through some examples last day where I showed every step of the calculation, but from here on out, I want to see all the values plugged in, right? Because you need to communicate to me that you know which values go where. But then if you skip straight to the answer, that's totally fine. Usually what I end up doing is I end up simplifying this, what's inside the brackets, and then show that that's times the PMT, and then I simplify. So I go almost to the very end, and then I can simplify. So the payment amount, the regular payment amount is $300. Times 1 minus 1 plus, and totally fine if you want to do store 1, if you don't want to write out that number, to the negative 48 over store 1. Because you've told me that this value is in store 1, that's why you're able to say, oh, okay, I'm not actually going to write that out. I'm just going to, or you can write it out. That's totally fine. Okay, so this is going to be the present value. So the present value, I'm going to simplify everything inside this bracket until I'm about to multiply by 300, and then I'll write it in. Just, I don't know, just for fun. So I have my I2, which is the store 1. So you want to start in the inside of the very most innermost brackets and then kind of bloom out. So you have 1 plus store 1, so recall 1, equals. Then to the power of negative 48, making sure the negative and the 48 is all in the power using brackets. So to the power of bracket 48 and then negative, using that plus minus button down by the equal sign, bracket equals, okay. Now I'm pretty sure I do 1 minus, let me just check. Yeah, 1 minus that, okay. 1 minus, and you could store it, or I like to use that second answer option, so second, and then over the equal sign is the answer. And it just brings in the most recent answer. Equals, make sure you hit equals, otherwise it just shows the most recent answer. Then divided by recall 1. Divided by recall 1 equals. So now I have 43.4406 something or other. I'm going to recreate the magic over here. Really recreate the magic because I didn't do any work on here. So I need to first find I2 minus 1. Okay. Plus 1 to the 48 negative. I'm getting there. Divided by, okay. 43.44, and I'm pretty sure that's what I got on the other calculator too. 063287. If you get something different, then let me know. So now, so you'll see in the next example even why I like to write it out just as a number times the payment amount. It's because eventually in the next example, we're going to be solving for the payment amount, right? How much do I need to be paying each month? So then what you would have is you would know the present value, and then you can simplify this side and divide it over to solve for the payment amount, right? And so that's why I like to show this value times 300. Now I can just say times 300, and because I want to keep it all on this page, I've got a page break here, so the present value, I'm just going to round it to a dollar amount right away. 13,032.18986, which I'll show rounds to 19 pennies. So that's the value of the car today, because that's how much you're paying off. Okay. Good. So the calculation with the compounding frequency and the payment frequency being different, the only thing that really changes is that it's really important that you find I2 first, but then the calculations all stay the same. The timelines stay the same, the questions stay the same. It's just, you have to make this adjustment, which we've been doing regardless, right? Even if they happen to be the same, we end up at the same I1 equals I2, but that's okay. It's better to have that mechanism in place. So I'll call that the end of our review. And I want to jump back to 6.3, where we calculate the periodic payment. Calculating the periodic payment, which is the PMT, and number of payments. Number of payments, which is your N. Okay. So what I want to do is just take you back to the formula sheet, right? So everything is on here. It's a lot to look at one go, right? So now I want you to focus on let's start with the payment amount. Oh. There is no formula for the payment amount, right? So there is no explicit formula for solving for PMT, but what you'll have, and like I was saying, what you'll have is you'll either have the future value or the present value, and then notice all the components in this kind of big bracket area, they're all the same. We need an I and we need an N, and it doesn't really matter what situation we have, right? We need I and we need N, but then we need to decide, do I have a future value or do I have a present value, right? Is this some loan amount that I'm about to be paying off, or is this some amount that I'm trying to save up towards, right? So depending on if you know the future value or the present value, right, that's going to determine which of these formulas to use, and then you can just rearrange and solve for the PMT, right? So depending on whether you are given the future value or the present value, sorry, that will determine which of these formulas you use, right? So depending on whether you're given future value or present value, that will determine which of these formulas to use to solve for PMT. Right. If you have I and N, or if you're able to solve for I and N more likely, and you have the future value, then you have everything you need to rearrange and solve for the payment amount, right? Versus if you have the present value, same deal, you can rearrange and solve for the payment amount. So let's do an example. So your RRSP goal is $300,000. The current interest rate for RRSP is 8% per year, compounded annually, and you intend to retire in 30 years. How large should your year-end contributions be? So what are your PMTs at the end of each year? Okay, so first things first, I want to just, what's the compounding frequency and what's the payment frequency? So it's compounded annually, and you want to make, how large should your year-end contributions be? Meaning your payments are also yearly. So the compoundings per year is 1, and the payments per year is also 1, making for a really nice, easy calculation here, right? So since they're the same, we know that I1 is going to equal I2, but just to go through the motion, there's no harm in solving for I2, even if they are the same, right? So just to get in the habit. So this is your frequency 1, and this is your frequency 2. So I2, going straight to I2, because it's going to be a really nice, easy calculation here, is 1 plus 0.08 divided by 1, right? 0.08 compounded annually, so divided by 1, to the power of 1 over 1 minus 1. Lots of ones in here, and I2 just puts me at 0.08, right? Which is I1 as well. So nice breezy calculation here, nothing to worry about. but it is good to get in the habit of just always finding I2 because that's the I that you should use. Okay, so what we want to find is if we map it out on a timeline, let's start today, and you want to retire in 30 years. So I'm going to make year-end contributions, and so here I am at 1 year, 2 years, and then dot, 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 same thing happens, 29 years, 30 years, and then I should have, right, I want to have $30,000. So whenever you're talking about saving money, right, some sort of savings goal, it's always going to be a future value. Okay. So what we want to find is we want to find some PMT here. So I'm just going to denote it by some payment amount that I'm trying to solve for. And all of these have to funnel to make some future value at the 30-year mark. And that future value has to be $30,000. That was the condition that we set out here. So here, this has to be 30,000, or sorry, 300,000. I don't know why I said 30,000. So 300,000 is what I need to have, right? And so this is a future value. Okay. How many payments am I making? Well, 30 years, once a year. Again, it's the time times F2, which is 30 times 1, which is 30 payments. Okay. So because I know the future value, right, if you think about the present value here would be 0, but it doesn't, if we use the present value formula, it wouldn't take this goal of 300 into account, so it just wouldn't work. So we're trying to save towards 300,000. So we want to use this formula here. So you want to use the future value, and maybe I'll just have it here and then I'll delete it. The future value is the PMT times 1 plus I to the power of n minus 1 over I. There. Since I have the future value. So I have the future value, I'm going to force it to be $300,000. Is the payment amount. And now I can plug in everything that I have, right? I is I2, which is 0.08. So I have 1 plus 0.08 to the power of 30, then minus 1 over 0.08. Okay. So now I can simplify these big brackets, right? Let's go to our calculator here. Oh, who's the liar? What the? Weird. I've never seen that one before. Makes me forget everything, all the calculations I wanted to do. 1 plus 0.08 to the power of 30 minus 1 over 0.08. Here we go. That's what I'm doing. I don't know if it's right. 1 plus 0.08 is 1.08. No surprise there. To the power of 30 minus 1 divided by 0.08. 113. I'm just gonna. That's how you would do it. Okay. Yeah. So I'm just going to do it on the side here. 1.08 to the power of 30 minus 1 divided by 0.08. Okay. Whee! So 300,000 is the PMT times 113.2832111. Make sure that you keep, so you can store that. I'm just going to use the previous answer option. So then the PMT, if I solve for the PMT, I have to divide both sides by 113 point blah, blah, blah. So the PMT is 300,000 divided by 113.2832111. So, and I'm trying to keep it on the same page here. This is going to be, and I don't like writing across the page, but otherwise this question's like 2 lines on the next page. $2,648 and 230016, which is 26.48 23 pennies because it's a payment amount. Good. So at the end of each year, you should be making a payment of $2,648.23 in order to have 300,000 in 30 years. And that's taking into account totally RRSPs, yeah. Hey, seems manageable, right? 2,648 a year. Oh. Well, might be a push, depending on where you are. Yeah, 8%. Yeah, let's talk about that. 8% per year is quite high. I don't think, I was just at the bank the other day actually, and they were claiming that they could get you 8%. I don't think so. It's probably quite a bit lower, but the idea is there. And it looks way more rewarding at 8%. Yeah, and then it depends on, again, how old you are. It's one of those catch-22s, right? If you're young, you don't have any money to put away, but then as you get older, you're closer to retirement, so you need to put more money away. Anyways. But this is the part of the course that I enjoy the most, because this is actual real life money things. Everything up until now is just kind of building up to this. Okay, so all right. So next thing I want to show you is how to solve for n. So solving for n requires a different formula, and it's on your formula sheet, of course. And so solving for n, I'll bring in the part of the formula sheet. Notice that you've got n as well as an n, and it's only because it's the same situation that we had here, right? It depends on if you have a future value or a present value. Notice, if you kind of, don't be too scared here. If you do a deep dive into the formula sheet, you see that there's a future value here versus a present value here. And besides the arrangement of everything else is the same, right? And so again, it depends on if you know the future value or if you know the present value. So I'm going to blow this up because otherwise it's hard to notice the difference. So notice that everything here is, or all the information, I should say, not everything is the same, but all the information, right? I and the PMT, those can be the same regarding, regardless of if you know the future value or the present value, right? And so depending on if you know, so again, the formula to use to solve for n depends on if you know the future value or the present value. If you know the present value, you can ignore this formula for n completely, right? And if you know, which one did I say? Obviously, if you know the present value, you can ignore the future value one. If you know the future value one, you can ignore the present value one. Seems reasonable enough. So I don't know, my hand is like super itchy. I don't know why. I haven't done anything different. Maybe a bite. First bite of the season. No, it's still too cold. So I hope not. So again, the formula to use to solve for n depends on if you know the future value or the present value. So it depends on if you know FV or PV. Okay. So we have this formula. And kind of everything that we need should be given to us in the problem. The only thing that we might need to do is to solve for I, which is going to be your I2 again, right? And so let's go back and grab that example that I want to do. Oh, loan shark Alec. All right. So N, remember, is the number of payments now, right? And so if we know the number of payments, then just like before in the compound interest case, you had to solve for N to solve for T. So now the problems are going to be kind of phrased the same. How long is this going to take to pay off, right? And so here we go. Maxwell borrowed $20,000 from loan shark Alec. Sounds bad. Alec demanded year-end payments of $3,500. How long will it take to pay off the borrowed money if Alec charges 17% interest compounded annually? Oof, okay. Already 17%, yikes. This is gonna be bad. Okay, so again, I want you to just take a moment, figure out what's your compounding frequency and what's your payment frequency. So we're making year-end payments. And I'm being really subtle about the year-end. In the next chapter, right, it's going to make a difference. Are these payments at the end of the year or at the beginning of the year? Right? Because and I'll get more into it, right? But while we're talking about it, because if I make a payment at the beginning on January 1st, then it would get to sit there and make interest until December 31st. Whereas if I invested on December 31st, then I miss out on all that interest, right? So we need to make adjustments. But for now, we're making end of the term payments. And our payment amount is $3,500. So what I want to do is let's just go through in exactly the same way that we've been doing. The compoundings per year is 1, and the payments per year happens to be 1 as well, right? And so when it's 1, this is F1 and this is F2. When it's 1, the calculation for I2 becomes really, really silly. But let's just do it, just to get in the groove it. So I2 is going to be 1 plus I1 to the power of F1 over F2 minus 1. You know what it is already. You're moving 0.17 to 0.17. Okay, fine. But let's just do it. 1 plus 0.17 to the power of 1 over 1 minus 1. 1.17 minus 1 is 0.17. So that's not always going to be the case, right? And so I need you to keep an eye out for that, right? Always calculate I2 first, even when it seems silly. You don't have to show the calculation. If you feel comfortable saying, oh, I1 equals I2, which is 0.17, that's fine. But just go through the motions if you're not feeling comfortable yet. Okay. Any amount that we've borrowed, so a loan amount, you buy a car, you buy a house, you borrow money from a loan shark, whatever, that's always going to be a present value, right? And so here, I want you to make a note, borrowed money is always a PV, Puerto Vallarta. I wish. Okay. So we can map this out, right? It's going to be kind of harder to map the timeline because we don't actually know how long it's going to take. But let's just visualize this. Let's just visualize this. So he's borrowing money today, and he's going to make year-end payments. So it's definitely going to take him a couple of years. So I feel safe doing 1 year, 2 years, and then same thing. I want the last 2 ticks. First 3 ticks, last 2 ticks. And then here, this is going to be n years. And it is n. And I feel comfortable doing n because it's year-end payments. So each year is worth n. If it was in monthly payments, it would be n payments, right? So because n is the number of payments. So this makes n minus 1 years, right? Just going back 1. Okay, so he's demanding payments of $3,500. So at the end of each year, we're going to be making payments of $3,500, $3,500, and last one. And these are all to pay off the $20,000 that he borrowed today, right? And so borrowed money is a present value because you're borrowing it today and then you're paying it off. Yeah. So here, these guys are going to funnel back to some present value. And I guess I should write 20,000 because that is what it is, but that is the present value. And then here, I'll do a n equals question mark because that's what I want to solve for. So because I have the present value, right, the formula that I need to use has to involve the present value, which is this guy here, right? And so okay. So I have I is 0.17, right? I have PV, which is 20,000. I have the PMT, which is 3,500. And then I have I again, which is 0.17. So at this point, I have everything and it's really just a plug and chug situation. So let's get to it here. I always regret, because now I say plug and chug a lot. And I used to have math parties when I was in school, in grad school mostly. And it would have been such a good theme for my math parties. Plug and chug. Regrets. Anyways. And is the negative log. Remember, I call the natural log just the log. Times 1 minus 0.17 times the PV, which is 20,000, divided by the PMT, which is 3,500. It'll always be I2. So for all of these formulas here, all of these, maybe that works. All of these formulas, the I that it's referring to is always I2. Okay. So let's see here. Let's go back. Okay, awesome. And then we have to divide by the log of 1 plus 0.17. Okay. So you have to be really careful, right? When you're simplifying inside here, you want to start at 20,000 divided by 3,500 times 0.17, then 1 minus that, and then take the log, and then divide by the log of 1.07 or 1.17, then negative it. If that's a term, it's not. Negate it maybe. And then you'll have your n. So going nice and kind of steady here. See if I can remember all these values going in. I'm going to start with 20,000 divided by 3,500. Then I need to multiply that by I, so times 0.17. Then I need to do 1 minus the 0.97. So I'm going to use the previous answer option. 1 minus second answer equals. Make sure you hit that equals, otherwise it won't do it. Okay. Then I need to take the log of this, or the natural log of this. Remember, this calculator, this financial calculator, needs to have whatever's on the inside on the screen already. And then when we hit ln, it'll take the log of it. So ln, and we get this negative number. This I'm going to store in 1, just for now. Okay. Notice that this is why we need that negative out front, because n has to be positive, right? You can't make negative payments. And so that negative out front is just to negate this negative, which will always happen. So now if I kind of parking lot this, right, this is the numerator, then I want to solve the denominator. So 1.17, I need the natural log of that, which is 0.157. So now I can store that into, if I want to. I'm pushing the negative outside for a little bit longer. But you can drop that negative and deal with it right away if you want to. Because now I'm going to do recall 1 divided by recall 2. And then I can do times 1 negative, or you could just drop the negative, that's fine. So you should get an n of 22.644988834. How am I ever going to remember that? Okay. 22.644. Okay. Because I really don't want to calculate it again. Oh, awesome. Thanks, Sid. 6. Oh, I did 2 4s. 6 4. Thank you. Oh, it is 2 4s. No harm, no foul. Good. Okay. So what does that mean? Well, n, remember n is the number of payments now. So it's going to take 22 payments and a bit, right? And so we're going to have to go for 23 payments. So we do that same thing. And I will say that maybe Moodle isn't that clever in its programming. So sometimes if it's telling you have the wrong answer, you might just want to use the non-rounded version. But technically we would need 22 and a bit payments making 23 payments, right, in general. So this is the number, n is the number of payments, right? So we would need n equals 23 payments to pay it off, right? Never mind that that last payment is not quite the full amount, that's fine. The total number of payments that you're making is 23. Okay. Or you're paying off a little bit more than you owe. For us, right, we're gonna just leave it at 23 payments. And because these are annual payments, right, n is in years, but just to kind of take it that last step, right, n is the time times f2, because it's the payment frequency. So 23 is t times 1. So the time is 23 years, which makes sense, right? Because we were making annual payments. Okay. Good. Let me go and have a look briefly at the examples I wanted to do. Okay. I think you guys are ready to learn how to use your calculator to do these things so you don't have to do these big calculations. But let's, how about we take a quick little break here until 11:05, okay? And then I'll teach you how to use your calculator to do these. Break until 11:05. Stretch your leg. The moment you've all been waiting for. How can I use my calculator? We've got these fancy calculators. Let's use them. So just a quick recap, right? We've already used our calculator to do some compound interest problems. It was kind of 50-50 on if it was faster, sometimes not really, right? But we established the basics of how to put stuff into our calculator, right? And so 6.5 is called, using your calculator or something. Using the calculator for annuities. So just as a recap for the calculator, right, to show our work, what we do is we have to list all our inputs, right? And so to list all our inputs, we start, and I'm just reading across the top row, the white row of buttons here, and it looks the same on the app, so, or similar on the app. So I just list them in order, and I want them in the same order. Otherwise, it gets really confusing for me when I'm reading them. So n equals the interest per year equals The present value equals the PMT. Hey, that sounds familiar. Equals. Future value equals. And then we also had the payments per year. Sounds familiar. Compoundings per year, also familiar. And then also let's talk about the beginning or the end mode. So we had the payments per year, compoundings per year, and beginning or end. Right. So let's just run through what each of these things are. N is now, because we're making payments, N is now the number of payments. Okay. The number of payments. So that's actually new, but that was new in our calculations too. So from our calculations, nothing's changed, but from the last time we used our calculator, it has changed a little bit. Okay. The interest per year is the rate as a percentage, right? So 6% compounded quarterly, you would put in 6, right? So the rate as a percentage, that is 6% is just 6, right? So not 0.06. You don't want it as a decimal, right? Kind of weird. The present value is, of course, the present value. So I guess I can just write present value. I don't know. The PMT is that regular payment amount. Okay. We were putting in 0, right? Because we didn't have a regular payment amount until now. So now we can put something in there. Then the future value is, of course, just the future value. The payments per year is of course, just the payments per year, which we've been calling F2, right? The payments per year is F2. And then the compoundings per year is F1. Compoundings per year is F1. Now, the beginning or end is if the payments are made at the beginning or the end of the term, or of the period rather. When payments are made. And what I want to say here is that the default is going to be the end, because you have to change the mode in your calculator to the beginning of the month or the day or the year or whatever the term or the period is. So the default here is going to be the end. Even, or especially I should say, on the final exam, if you are not sure which one, if it's the beginning or the end, I want you to use the end, right? So if you're ever not sure, use the end, right? And if it's supposed to be the beginning, then it'll explicitly say, right, at the beginning of each month, at the beginning of each year, or something like that, right? But the default, if you're ever kind of not sure, just use end, okay? So let's see here. Oh yeah, what was the other convention that we established? We didn't quite use it, but we said that money leaving our hands has to be negative, right? So anything, and if you think about the money leaving your hands is kind of fluid. So it can be, you know, you make a deposit into an RRSP, let's say. So as soon as you're making a deposit, even if it's going into your bank account, we think of it as leaving your hands, right? You're making this deposit and then you take it out and then we make that positive. So that only applies to these dollar amounts. Okay. I'll write in a darker green. But we use the convention of money leaving our hands is negative and money coming to us is positive. So we use the convention of money leaving our hands is negative and money coming to us is positive. Okay. And that's going to take some practice, right? Figuring out, okay, is this positive or is it negative? But it's going to be really important because if you, let's say you borrow, well, let's go back to that other example. You borrow $20,000. And then if you forget to make your payments, so any amount that you borrow would be positive, right? You get that amount because you borrowed it. So borrowed amounts are going to be positive. So here I'll just say borrowed amounts will be positive, right? Because you get it, it comes to you. Payments that you make to pay off that borrowed amount should be negative, right? Payments made will be negative. Unless they're coming to you, right? So here, when I say payments made, these are payments that you make. Okay. Or if you kind of flip the switch and think about, okay, how does a pension work? Well, you pay into a pension, and then at some point, kind of the tables turn, and then you get payment amounts instead. So it depends on what the situation is, but payments made will always be negative. Now imagine that you were trying to, in your calculator, right, you were saying, oh, I'm making these payment amounts, but if you forget to make them negative, right, you're technically telling the calculator that, oh, and then every month after that, I borrow $3,500, right? Which would just add on to how much you owe, and it wouldn't pay anything off, right? And so that's going to be reflected in the future value. So that's not good, right? And so you want to keep track of those. All right. So let's do an example, and I want to do it by hand first, and then do it on the calculator. So because we can do both, it's just sometimes the calculator is going to be a little bit easier, or quicker rather, maybe not easier. Okay. So I'll make a note here. We will first solve this by hand. By hand. Then using the calculator. Just so you can see how they kind of match up. You can just do all these calculations by hand always. It's just that come final exam time, and even test 3, you might run out of time because the calculator is so much faster. Okay, so let's do the by hand section first. So by hand, here we go. How would I approach this? First things first, what's my payment frequency? What's my compounding frequency? So I guess I should read the question first. Tom and Delilah wish to start a college fund for their daughter. How sweet. Their goal is to put $200 into the account at the end of each 2-week period, so bi-weekly. Assuming the college fund will earn a rate of interest of 3.75% compounded quarterly, how much will be in the account in 20 years? So I've got my compounding frequency is quarterly, and 2-week period is bi-weekly. So, okay, finally something different here. The compoundings per year is 4, and the payments per year is 26, right? And let's just make a note here. This is my F1 and this is my F2. These are not the same, so I definitely have to find I2, and then that's the I that I'm going to use in my calculations. So here we go. I2 is 1 plus, oh, I forgot to write the 1. 1 plus I1 to the power of F1 over F2, then minus 1. You can calculate I1 on the side if you want. I'm just going to do it inside here because why not? So I have I2 is 1 plus 0.0375 compounded quarterly, going from quarterly to monthly, and then, sorry, not monthly, bi-weekly, 26, and minus 1. So I2 is this. And let's see here. I'm just going to do it on the side because the main event is using our calculator to do these later. So we're just practicing by hand here. 0.0375 divided by 4, and then plus 1 to the power of 4 divided by 26, and then minus 1, I am getting 0.00143662, which I am going to store in 1. Hopefully you got something similar. Okay, so now I can map this out with a timeline. So, and the timeline is going to stay the same, right? I still want to ideally see a timeline regardless of if you're doing it by hand or on a calculator, but if you're using the calculator, you don't need to. It just helps you figure out what you need to do. So their goal is to put $200 into the account at the end of each 2-week period. So we're talking bi-weekly here for a total of 20 years. So I'm going to start today, and then I end at 20 years. But we're making bi-weekly payments, so I'm just going to write 1 bi-weekly, 2 bi-weeklies, because if I do 2, 4, 6, 8, it gets confusing, right? And it's really just to map out what's going on. And in 20 years, 20 times 26 makes 520 bi-weekly payments, which makes the second to last one 519 bi-weekly. Connect those with a dot, dot, dot. Okay. They're putting $200 at the end of each 2-week period. Okay. And then we want to know how much will be in the account in 20 years. So we're assuming that they started with nothing. There's no mention of anything in the account initially today. And so we want to find the future value, right? How much have they saved? So they're making payments of 200, 200, 200, 200. And then we want to funnel all these guys to some future value, and that's the one we're interested in. So the future value formula that we have to use is, I'm just going to grab it from our formula sheet, is probably the easiest. These ones, it takes me a couple of days to memorize these. I will have them committed to memory, but not yet. Future value is the PMT times 1 plus I to the power of n minus 1 over I. And this I here is again I2, right, which we calculated. And that's why it's so important that you use I2 and find I2. So the future value is going to be $200 times 1 plus, and I'm just going to write store 1. N is the number of payments, right, which is 520. Oh, and I forgot to do that here. N is time times F2, which is 20 times 26, which is 520. Just completeness. So to the power of 520 minus 1 over store 1, or I guess I should write recall 1. I don't know. Store 1's easier to write. All right. So now I am just going to do these calculations. We've already done these. I've shown you how to do it on the app, but just makes it quicker if I just do it here. So 1 plus recall 1 to the power of 520, then minus 1, then divided by recall 1. And again, I'm just going to do 200 times 772.3801011, which times 200, 154,476.0202, which means after 20 years or at the 20-year mark, what they would have is they would have $154,476.02 saved after 20 years. Whee. Okay. How about on our calculator? On our calculator, so again, we have to list all our inputs, and later I'm going to copy and paste them because it gets really tedious and because I can. But for now, we need the interest per year, we need the present value, we need the PMT, we need the future value, we need the payments per year, the compoundings per year, and beginning or end. Okay. So, and we already know. So here's where I find that it's easier if you've drawn a timeline. You don't necessarily need to, but I do find it's easier, right? And so from the timeline, we know already that N is 520, right? N is the number of payments, which is 520 payments. The interest per year was 3.75, I want to say. Yeah. 3.75. The present value is 0 because the 0 here, right, they started with nothing in the account, right? Started with nothing, or at least there was no mention of, oh, they already had $20,000 in there, right? Then we could put that in as a present value, but They started with nothing here. They're making payments of $200, right? And so it's really important that you do negative 200 as the PMT, right? Because they're making payments. Which means it has to be negative. Because it's leaving their hands. It is going into their account, but as far as, well, money had to come in and then it's going out, and it happens to be going into that account. And being able to think about, like, is the money leaving my hands or coming to me? It's going to take some practice. The future value is what I'm interested in, right? And so that's where I'll put a little asterisk, because that's what I'm trying to find here. You can fill it with 0 temporarily if you want to. The payments per year, they're making biweekly payments, right? So the payments per year is now 26. Whereas the compoundings per year, I think, was quarterly. Let me see if I have that example. Quarterly, yeah, so 4. And the payments are being made at the end, but also we haven't talked about beginning yet, so far it has to be at the end. But we'll be prepared for when they're at the beginning, because then we just change the mode. Okay, so I'm going to plug this all in, right? And let's see here. See if I can remember all these values. So the n was 520, and remember how you do it is you type in the number, and then you kind of goes into n, and then 3.75 goes into the interest per year. So 520 into n, 3.75 into the interest per year, 0 into the present value, 200, and then to make it negative, notice the plus minus button right by the equal sign there. That's how you're going to make it negative. So 200 negative is going into the payment amount. Future value, I'm going to temporarily fill it with 0, and then I'm going to go back and compute it, but you could just skip it if you want to. It's been a while since we used our calculator, right? So to get to the payments per year, you have to go second payments per year. And then to store anything in the second menu, you have to hit enter, right? So the payments per year is supposed to be 26. Notice that it's missing the equal sign here, so you have to enter, and then it stores it. And then you can use the down button to scroll down to the compoundings per year, which will automatically adjust to be the same as the payments per year. But now we don't want that. We want quarterly compounding, so 4, enter, otherwise it doesn't save it. Now what I want you to do is scroll back up to the payments per year and just make sure it's 26 and that the compoundings per year is still 4, right? You want to make sure that they're not the same anymore. This is the reason that you don't have to find I2. What a time saver, right? You don't have to find I2 if you're using the calculator, because it's doing all that work behind the scenes. So let's see here. Compoundings per year. Next stop, beginning or end mode. Just as a refresher, we can just leave it in end mode. But if we go to, so if you want to exit out of a second menu, you have to go second quit. And then the begin mode is over the PMT button. So second, begin, it's at the end, and you can hit second set to go to begin, but we don't want that. So second set again, and to make it at the end. Until you change it, it's just going to stay at the end. So just leave it at the end until you need to change it. Second quit to get out of that menu. And now I'm ready to compute the future value. So I have to hit CPT compute future value. Notice that I get a positive value here. Even if it was negative, the negative would mean that I would have to pay that amount. It's not a negative dollar amount. It's just the direction that the money is going, right? And so the dollar amount is always just going to be, without the negative, if there is one. It's just telling you the direction. Now, in this case, it's positive. So I get 154,476,0202. Sounds familiar, right? Should sound familiar. I get 154,476,0202, which is the same as what we found, hopefully what we found here, right? Which is the same we found by hand. Which is good, right? That's what we want. So as long as you keep track of the negatives, right? What amounts are negative, what amounts are positive, it's going to be a lot quicker to use your calculator, right? And so notice when we use our calculator, we do not need to find I2 because the calculator does it for us. Because the calculator does it for us. So that's nice, right? Okay. How about we do an example where we only use the calculator? This is going to be one of those where we start with some amount in the account. So we need to kind of keep track of what that means. So for this one, I'm only going to use the calculator, but I will draw a timeline just to illustrate what's happening. Like I said, the timeline is sort of optional. I would love to see timelines for every question, mostly because I find that it helps you get on the right track of what you're trying to solve for. But it is just kind of a tool, so use it. I encourage you to use it. We want to, so here it flat out says, compute the future value. Okay, fine. Can do. Of an RRSP, which is currently worth $25,000 and will increase in value with month-end contributions of $500 over the next 12 years. So starting today, we have $25,000 in there, but then at the end of each month, we're going to be adding $500 for 12 years. And here we've got this huge RRSP interest rate of 9% per year compounded semi-annually, right? And so what I want to do is I want to just map this out, right? So the timeline here, I start today, and in 12 years from now, that's where I'm done. I'm going to be making month-end contributions. So my ticks are going to be at the month mark. So 1 month, 2 months, ... 12 years is how many months? 12 times 12 is 144 months. So the second to last one is going to be 143 months. I'm going to draw these payment amounts first. So $500, $500, $500, and $500. These are all going to go forward to some future value at the 12-year mark. But then I also have that 25,000, which is just going to be sitting there. So instead of trying to kind of combine the 25,000 with the 500, I'm actually just going to let them sit there and work independently, which would involve two calculations, right, if you're doing it by hand. But our calculator can just do it right away. So that's why I'm using the calculator for this one. So we started with, 25,000 here. Now the difference is there are no payments here. Okay, so this 25,000 is just a normal compound interest problem, right? We invest some money, it sits there for 12 years. How much do we have at the end? Versus this future value is an annuity, right? And so we would need to use two different formulas, but we're not doing this by hand. We're doing it on our calculator. So the future value here, notice that this is compound interest, right? No PMT is happening here, and this is an annuity. So we would need to do different calculations, but then the total here, if you add these up, that's the total future value. Our calculator can handle these situations very easily, right? Because here, this is a present value, right? This is the amount that I started with. In the last example, we said we start with nothing. Okay, fine. Now we're starting with 25,000. Fine, we can do that. We can just plug it in as the present value. And then it'll take care of these calculations. And the N is still going to be the number of payments, right, which is 144. Okay. So, because then it'll just kind of, make that adjustment down below here. All right. So here we go. I'm going to cheat and grab these calculator inputs. Not move them, copy. Paste. Hey, and it just kind of works out that, again, I'm trying to find the future value. All right. Because the question says, compute the future value of an RRSP, which currently has 25,000 in it and will increase in value. Okay, 9% compounded semi-annually. So as I read through this, I'm going to jot down the information in my calculator inputs here. N is still the number of payments, which is 144, right? Which is what we found for our timeline. The interest per year was 9, I think. Yep. 9, and while I'm at it, it's compounding semi-annually, so I'm just going to jot that down as well. 2. Currently worth 25,000. Now here's where you need to think, is this 25,000 positive or negative? Positive would mean that you would get it and then you can go spend it. That's not the case, right? So what we're going to pretend is you take that 25,000 and you just freshly put it in, right? And so because you don't have it to spend, you just deposit it into this RRSP. So we have to make it a negative amount. So it has to be negative 25,000. Right, because it's leaving our hands and it's going into the RRSP. Right? I'm making payments of $500, and again, these are making payments towards my RRSP, so they're leaving my hands and going into this account. So again, I have to make negative payments, right? money is leaving our hands into the RRSP. Okay. So the payments per year were monthly, right? So here, month-end contributions. Okay. This is also where you're going to find if it's at the beginning or the end. So month-end contributions is at the end. Okay, so the payments per year is 12, and it's at the end. Okay, 144.9. Just trying to commit these to memory so I go to the other page here or the other screen. Okay, so here we go. Remember that it keeps all the values from the previous calculation or the most recent calculation until you overwrite them. So you don't need to clear them or anything, you can just overwrite them. So now N was 144 into N. The rate was 9 interest per year. The present value, and here's where it's really important, 25,000 negative, right, is the present value. The payment amount was 500, but also negative. The future value is what I want to find. So I'm going to put a 0 in there temporarily. So I'm going to go 0 future value, just why not? I need to adjust my payment frequency and my compounding frequency. So second payments per year, monthly payments, right? 12, enter. And then the compoundings per year, now I'm drawing a blank. You want to say, I've got the, can steal it here. Semi-annually. 12, sorry, 2. 2, enter. Okay, so monthly payments, let's just make sure. Payments per year, 12. Compoundings per year, 2. I was so close to remember everything. Okay, whatever. To get out of the second menu, I have to go second, quit. And now I can go and I can compute that future value. So compute future value, and I get 199,292.8821. And maybe I have it here. Yep. So I find positive 199,292.88. I think it was 21. I just want to have all the decimal places that it gives me. It being positive is just telling me that, okay, so the idea of investing into an RRSP is you're investing, and then at some point, the future value, you can take it back and it's yours, right? And so that's why it's positive. So they would have, or it's not they anymore, just compute the future value. The future value, so after 12 years with this setup, right, we would have $199,292.88, right? So after 12 years, we would have $199,292.88 in the RRSP. Okay, so practice those, but I do think that you're gonna quickly grow to appreciate this financial calculator, especially because there's a free app and whatever, but play around with it. And you can always go back and try all of these problems that we did solve. You can go back and you can confirm them with the calculator, right? And so even if you have to solve for n, right, it can do that, which is the only other thing. It can solve for the payment amount, right? And so you can solve all these problems using the calculator just to get some practice. All right, so next day we're going to start chapter 7, which is just when payments are at the beginning of the payment period. We don't, because, so here, the beauty of the calculator is that we don't need to deal with this mess, because that would be a lot of hand calculations, right? Because we told it that, okay, we actually started with this 25,000, it'll just do that in the total calculation, which is pretty cool. So that's where the 25,000 is. Awesome. So go through those problems that we did go through and just confirm with your calculator so you get really comfortable with your calculator, because it's going to be so much faster. And then, like I said, next day we'll start chapter 7. Wherever we get to by the end of next day, that's where we'll do our test up to. So yeah, anyways. If you have any questions, let me know. Yeah, you've got 2 assignments and a quiz due tonight, I think. Maybe check those out. Quiz is meant to be easy, or quick at least. And as always, the quiz, I'll go through and I'll check the answers. If it should have been marked right, I'll adjust your grades. But yeah. Okie dokie, artichoke. I also posted another assignment, but it's not due till next week, so don't worry about that. Yeah, plus your other assignments and stuff. All right, so if you have any questions, let me know. Otherwise, have a great Easter, and yes, I will give you a practice test. I just forgot about the test, so I have to make it, but it'll be there.
Thanks, Emily.
Thanks, guys.